In North America, side-loading trucks have become the new norm in waste collection. These trucks are efficient, safe, and eliminate risk exposure associated with traditional waste collection.
One major issue that the city of Lethbridge and many other cities are dealing with is the wind. Being the second windiest city in Canada, it is common to see sustained wind speeds of 70 to 80 kilometers per hour, with peak gusts hitting 120 kilometers per hour. This causes the recycle bins to fall, spread waste, and in some cases run away from their place.
Fortunately, we have a solution, presenting the Ballast Tank Stopper, or BTS for short. This consists of an external ballast filled with water and antifreeze to add weight and increase surface contact with the pavement, as well as a wheel lock that prevents the bin from rolling away. This design will be effective by significantly reducing the possibility of the bin tipping in strong winds. We have considered weather constraints to ensure durability, made sure it is easy to use and implement. The design will be fully compatible with the side-loading trucks and manufactured at a low cost.
When designing our idea, we had to consider what type of material we would use. We created a simple spreadsheet comparing 4 different materials: low-density polyethylene, high-density polyethylene, PVC, and timber, which was our control variable. From the spreadsheet, we can see that HDPE runs in most tested. These are its density, coefficient of thermal expansion, elastic coefficient, yield strength, and cost. Although PVC may seem like the best choice, we decided to use high-density polyethylene as its statistics are still as good, and its ductile temperature range is from -70 to +70 degrees Celsius. This means that it will be able to withstand much more extreme weather conditions better than PVC, which has a risk of becoming brittle at extremely low temperatures.
Next is the motion study part. In this design project, we increased the bottom weight of the recycle bin and fill the ballast with appropriate materials to make it have greater wind-resistant ability, and this ability keeps the recycle bin from falling down. Then is the exploded structure of the bin. The stability of the bin and bottom ballast keep the bin standing under the high wind weather. Ballast at the bottom of the bin can be filled with water or sand, so the stability of the bin can be ensured. After we collapse it and apply it to the real life, as you can see, the designed ballast fits perfectly with the body of the bin, and the opening or closing activities of the lid does not rub against the ballast. Furthermore, the ballast does not affect the motion of the bottom wheels. You guys can see the detailed design in the video.
We wanted to ensure the ballast provided enough weight to keep the bin from tipping. In order to prevent tipping in sustained winds of 70 to 80 km per hour, we calculated that we would need a weight of at least 26 kilograms in addition to the weight of the empty bin to prevent the bin from tipping over. To find this weight, we used the basic tipping force formula, as shown above, in order to counteract the amount of force from the wind pushing on the body of the bin.
Here we can see the full design, followed by sectioned views to expose the interior. This hollow reservoir was created using a simple shell feature in SolidWorks. However, in practice, the high-density polyethylene would be injection molded into shape. A removable threaded cap is positioned near the top of the ballast so that residents can add water using a garden hose. A second cap is located near the bottom for easy drainage. Alternatively, if more weight is desired, sand can be added in place of water without compromising the design's function. In terms of installation, our attachable water ballast comes as one pre-assembled part and makes no permanent changes to the existing bin. Attachment simply requires sliding the empty bin on top of the ballast and securing 4 clamps, 2 around the handles and 2 around the front bar, which can be done using a simple screwdriver. Overall, throughout the design process, our group sought a solution that was durable, cost-effective, easy to manufacture, and easy to use. We believe that our maintenance-free system checks all of these boxes without putting any extra burden on the residents of Lethbridge or on the recycling collectors.